Okay, it is time to put everything together and graph rational functions by hand. Okay, we're going to take everything that we learned and put it to use and see if we can get a cute picture. So the first thing we're going to do here is factor r of x. Let's get r of x into factored form. The numerator is going to factor into 2x and x. And let's see, how can we make a 12 where the outers and inners make -2? Let's say 2x plus 4 and x minus 3. Is that going to work? 8, -8 plus, or -6 plus 4. Okay. Actually, I think we can take a 2 out of here in just a second. Let's finish the bottom first. X minus 3 times x minus 1. Oh, I noticed some things happening. Okay, domain. All reals except which x's are not allowed in this graph? +3, +1. But when a factor cancels, that's going to make a whole. So the whole is going to be at 3 comma something else. I know that I can go ahead and take out a 2, so that's going to be x plus 2, and the denominator is x minus 1. Okay, so simplify the equation. We did. Let's take 3 and plug it in so we can get our y value for the whole. That's going to be 5. X-intercept. An x-intercept is you set y equal to 0. We can use the old one or we can use the new one. I recommend the new one. If you set 0 in the y place, that's going to be 2 times the numerator stuff, x minus 1. If we put 0 over 1 and cross multiply, the first thing that I notice is 0 times stuff in the bottom cancels out and makes a 0, and all we have left is the numerator. So when it says y equals 0, there's actually a shortcut, and you can find the x-intercept by setting the numerator equal to 0, because every time the denominator is just going to cancel out. So here I think we're going to get x equals -2. So the x-intercept is -2 comma 0. Y-intercept, there you set x equal to 0. So that's going to be 0 comma, let's see, if we look at the new simplified form, you put 0 into the x spots. 2 times 2 divided by -1, that's going to be -4. Are there any vertical asymptotes? You look at the simplified form, and yes, there's still a factor down there, so x equals 1. And let's figure out some end behavior. Looking at the original graph, I notice the powers are equal. You can look right there. Or you can look at the simplified one. I notice the powers are equal. So you would take the leading coefficients. Either way, I think he's going to have horizontal end behavior at y equals 2. So he does not have any of those. Okay, let's go put all this information on a graph. I'm going to go ahead and zoom in here a little bit so we can really see what's going on. The vertical asymptote is at 1, so let's go ahead and put our vertical asymptote on the paper. He's got a horizontal asymptote at 2, so let's put that on our paper. And now we have to talk about some other things. The more information, the better. He's got a hole at 3, comma 5. So let's put that hole on the graph. I know the graph's going to be around here because that's where a hole is. There's a break in the graph there. The x-intercept is -2, and the y-intercept is -4. Okay, what you're going to have to do is put your pencil somewhere on this paper to start. I'm going to pick this x-intercept, and I know the graph, as it goes to the right, is going to be headed over here towards that y-intercept. Now, does the graph go back up and touch the x-axis here? No, there's no x-intercept, so I know it's got to go down, 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 like that. Over here, the graph is going to come up and approach that asymptote, but not cross it. Over here, put your pencil near that hole, and the graph is going to go up, approaching these asymptotes, but not quite touching them. And so you have just drawn your first rational function. I'm going to put a little note over here on the side, because people often ask me, how do you know how many pieces you're going to have? Well, let's just take a look. If we happen to have two vertical asymptotes, then that means you're going to have 1, 2, 3 sections. You're going to have maybe a piece of a graph here like that, maybe you'll have a piece of a graph here like that, and then maybe you'll have a piece of a graph here like that. If there's 2 breaks, then you're going to have 3 pieces. Okay, let's go take a look at a couple more. The more you do, the faster and better you're going to get at these. In the beginning, people get a little scared that they're not sure how the picture is going to look. But the more holes and information you have, the easier it is, actually. Okay, the first thing we're going to have to do here is get this guy factored. And I think we're going to have to do factor by grouping. So let's go ahead and do factor by grouping there. Take out, that's going to be 4x squared minus 1, and that's going to give us x minus 1. The denominator factor is regular. This is 2x and x. I got to have a 5 and a 1, so I'll put the 5 here, 5 and a 1, and then if I make them both negative, negative, that'll give me negative 7. Oh, I noticed some common factors. Let's say the domain while we're looking at this before we cancel it away. All rails except x cannot be 5 halves or 1. There's no graph there and there's no graph there. Okay, but maybe for different reasons. Let's simplify this. R of x equals, after we cancel, I noticed that numerator there can go ahead and get factored a little bit more. So let's figure out the difference of squares there. 2x minus 1, 2x plus 1. Okay, so nobody else cancels away. But that one factor does make a whole. 1 comma, let's see, maybe I'll put 1 in here. That's just a little easier to calculate. 4 minus 1 is 3. If I put 1 here, that's negative 3. So we're getting negative 1. Okay. X-intercept. You could put 0 for y, but as soon as you cross multiply, remember the easiest thing is to set the numerator equal to 0. So you look in the numerator for x-intercepts. So we're going to have 1 at 1 half comma 0 and negative 1 half. I'll say plus minus 1 half comma 0. The y-intercept, if I put 0 in for the x, I could put it in here, I could put it in here. I can even go back to the beginning if I'd like. If you put 0 into all these x places, all that turns to 0, and then we simply have 1/5. That could have happened over here. Here it's just getting a little harder when it's in factored form. Are there any vertical asymptotes, any denominator quantities left over? Yes, x equals 5 halves. And now let's talk about end behavior. If you look at any of these versions, I'm noticing that he's top-heavy. What do you do when a rational function is top-heavy? Class? Ah, that's right, we're going to do some long division. Now remember, you could do long division with the old one or the simplified new one. I think this one right here that's not factored is going to be the easiest for long division. The numerator goes in the divide box. 4x squared. Don't forget your x plus 0x. And then we have minus 1. And we're going to divide by 2x minus 5. Okay, let's look. The first thing I notice is he's missing a 2 and an x. And what do you do with that? You multiply your divisor. So 4x squared minus 10x, and it's time for change, change. The first term cancels, as it always should. The second one is 10x. Thank goodness I had that column there. We have to keep going because he's not bigger than our number here, so we could still fit in a positive 5. Are you getting good with noticing that after this point, we're definitely going to be done? So I think I'm just going to go ahead and say ignore remainder. I am positive that that's the final one. So did we have horizontal asymptote? No. And our quotient ended up being linear, so it's not other, it's oblique. Y equals 2x plus 5. All right, let's go get all this information on a graph. I am going to put a little note here to kind of help you understand. When you have a vertical asymptote like that, okay, the vertical asymptote is going to do something to the graph. A vertical asymptote splits the graph. Now, unless you have a factor repeated, but we don't, our vertical asymptote is just a single factor right here. So he's not going to go up, up, okay? We're going to have a graph that gets split. So as you approach the asymptote on the right, you're going to go up, or vice versa. And then on the other side, you go down, and then the graph splits. And that's what a vertical asymptote does. Okay, so we have one of those this time. And last time. Let's put our vertical asymptote at 2.5. Vertical asymptote. Let's see, what else do we have? Oh, we have an oblique asymptote. That's interesting. That is a diagonal line. The y-intercept is 5. And then we go up 2 over 1, up 2 over 1. So we've got an asymptote like that. We go down 2 over 1, down 2 over 1, down 2 over 1. I'm going to make sure this is nice and accurate. Down 2 over 1, down 2 over 1 off the graph paper. Okay, so these are asymptotes that are going to help me draw my graph. Anything else we have will also help. We have a hole at 1, -1, so I know there's going to be graph around here. The x-intercepts are at ±0.5. Okay, that's good to know. You got a couple of points to aim for. And the y-intercept is at 1/5. And I believe that's all the help that we get. So let's start by all these points. I know the graph goes from here, goes up, it touches that one, approaches the hole. There's no graph there. It looks like the graph has to go down, down, down. On this side, I think it's going to approach the asymptote closer, closer, and follow that. Okay, now I know that we are not done. This is not enough graph. Okay, just like I said on the last page, if you have one asymptote, you're going to have 2 pieces of graph. Right here, I see the graph going down, down, down on the left. That means it must be going up, up, up on the right. The graph got split along that vertical asymptote. Now, where's the rest of this going to go? It's going to follow the asymptote that way. And so if I cover up all the good stuff in the middle and I ask you, what do those ends look like? You should tell me they look like an oblique line. And that's exactly what the end behavior was, an oblique asymptote. Okay, let's just write down a couple of notes here for you. Make sure that you actually approach the asymptotes. Sometimes we have people not get anywhere near the asymptote, and that's not correct. One vertical asymptote is going to make 2 pieces. 2 pieces. One asymptote, 2 pieces. So make sure you have piece on the left and then you have graph on the right. Remember, you're supposed to have graph everywhere except those 2 places. So where's your graph for 5, 6, 7, 8, 9? Okay, don't worry. You're going to get a lot better the more that we do. Let's go look at the next one. Oh, goody. I can't tell you how exciting this is here looking at all these terms. The factoring is certainly juicy. I think we're going to do some factor by grouping. Factor by grouping here. So why don't you pause the video and see just how much factoring you can get. All right, let's take a look at this here. At some point, you probably should have taken out a 4. If you didn't do it first, then you'll have to do it later. We have x squared minus 7 and x plus 2. The denominator factored also into x squared minus 16 and x plus 2. Okay, now that is nowhere near done, and I am noticing a hole. So before we start canceling, let's write down the domain. All rails except you are not going to use, oh, careful here, there's 2 of them, plus or minus 4 and -2. So we'll go ahead and cancel those factors. But this is not completely factored yet. So r of x in completely factored form needs to have a difference of squares factored on the bottom, x minus 4x plus 4, as well as the numerator. The numerator factors into x plus and minus radical 7. Did you figure that out this time? We've been doing a little bit of that lately, so hopefully you caught on to that. There is a hole at negative 2 comma something. I'm thinking it might be easier to go up here before we factor it and plug in negative 2. Put negative 2 in. 4 minus 7 is negative 3. Negative 2 squared, 4 minus 16. That's going to make a 1. X-intercept. Remember we said where to look? Look in the numerators. Look in the numerators. And the numerators are factored. So we're going to have intercepts at plus minus radical 7, comma 0. Y-intercept, let's put a 0 in for x. Maybe it would be best to go to this form right here. If you put 0 in for x, that's going to give you 4 times negative 7 over negative 16, which simplifies to 7 over 4. You also could have gone to the original if you want to put 0 in for all those x's and just look at those two constants. This one's a little more work because you have to multiply things out, but you're going to get the same answer no matter where you look. The two x's that are left are vertical asymptotes. You've got plus and minus 4. And let's talk about end behavior. This equation has powers that are equal. So you can look at the original one. You can look at the simplified one, the totally simplified one, wherever you want to go. He has horizontal asymptote at y equals 4. Nothing here, nothing here. Okay, let's go ahead and make a graph. We have asymptotes at x equals plus and minus 4. So we'll get those in. We've got a horizontal one at 4 as well. 1, 2, 3, 4. Okay, I hope we have some more information because this is not going to be enough. We have a y-intercept at 0 and 1 and 3/4. X-intercepts are plus and minus radical 7. Radical 7 is about 2 point, who cares, 2 point something, and then negative 2 point something. Just get in the middle of the box. And, oh, we have a hole. We have a hole at negative 2 comma 1. Okay, I think I can tell what's going on here. I can see that I have to connect this point to this point to this point. There's a hole in the graph. There's a point. It's going to go down, down, down. And this one's also going to go down. I know it can't go back up. You are not allowed to have any other x-intercepts. Okay, I'm going to put a little note right here. I see 2 vertical asymptotes. Okay, 2 vertical asymptotes are going to make how many pieces of graph? That's right, 3 pieces. Okay, so we are not anywhere near done. Let's look at this vertical asymptote. If it went down, down, down on the left, it's going to go up, up, up on the right, and then approach that asymptote. Over here, cover everything up with your hand and take a look at that asymptote. It went down, down, down on the right. So that means it's going to go up, up, up on the left. And then we'll follow the asymptote. Let's just cover everything up here for a second. What do the ends look like? Do the ends look like a horizontal line? That's perfect. The ends were supposed to go horizontally. Okay, looking real good. Our last one is going to be a good one. The factoring here does work out a little nicer. We're going to have x squared and x squared. And then the 9 is going to be a negative. Negative minus 9 minus 1. Down here, this one can also factor. We've got a lot of different squares here. The thing is, I don't think any of them cancel out. So x plus 3, x minus 3, x plus 1, x minus 1. Some people ask, why do you factor everything out like that? Well, it makes a lot of the questions that I'm going to answer easier if I can see all the numbers. I could see my x-intercepts, I could see my vertical asymptotes, because it's in factored form. If I need to do anything, I could just look back at all these other versions. So the domain's all reals except you cannot be plus or minus 2. Do we have any holes in this graph? Nope, no holes. X-intercepts, you put 0 in for y, the denominator is going to cancel, so the easiest thing is just look in the numerator. So we have 4 of them, plus minus 3 comma 0 and plus minus 1 comma 0. It's going to help me graph. The more information, the better. Y-intercept, we put 0 for x. I think it would be best to go back to the original. 0, 0, 0 all cancels out, and that makes negative 9/4. Okay, that is looking good. Vertical asymptotes are going to be at plus minus 2. And let's talk about end behavior, examining the powers. The degree on top is 4, the bottom is 2, so what do we have to do? Ha, that's right, long division. Let's go ahead and put some x's in the divide box. X to the 4th plus 0x cubed minus 10x squared plus 0x plus 9. The divisor does not need x's, just leave him like he is, and let's look. The first term compared to the first term is missing, x squared. X to the 4th minus 4x squared, and then we're going to change, cancel that out. I didn't use that x, sorry, you go away. Let's add these terms together here. Negative 10 plus 4 is negative 6x squared. I'm going to bring that x down just in case I need him. And we can still do another step. We're going to compare the first and the first, and he's missing negative 6. Can you tell that's going to be the last time you can do it? So what kind of end behavior is this graph going to have? It's not horizontal, and it didn't end up being oblique. This one is going to have the ends follow the graph of a parabola. That's going to be quite interesting. All right, it's time to put the pretty picture together. Let's zoom in close for all my friends in the back. Who's sitting in the back? You're all at home. Okay, the vertical asymptotes are at plus and minus 2. Plus and minus 2. What else do we have? How about the end behavior? It looks like a parabola shifted 6 units down. Okay, parabola 6 units down, and then it goes over 1, up 1. Over 1, up 3. 1, 2, 3. Over 1, up 5. 1, 2, 3, 4, 5. You have to make sure when you do the asymptotes that you do not draw them solid. These are not part of the graph. Over 1, up. Okay, right there to the edge of the paper. These are asymptotes that help me draw a nice clear graph, but that's not part of the graph. I haven't even started drawing the rational function yet. Let's see. How about our intercepts? I'm going to put one intercept on the y-axis at negative 9/4. That's negative 2 point something. The x-intercepts are, 4 of them. Negative and positive 1, and then negative and positive 3. Okay, we got some interesting things happening here, but that's all the help you get. All right, let's start maybe in the middle section here. I can tell the graph is going to go from here to here to here. Now, where's the graph going to go? I think it's going to follow this vertical asymptote. And the same thing over here. Follow the vertical asymptote. Okay, that's good. Now, what about if you go up, up, up on the left of a vertical asymptote, then we're going to go down, down, down on the right side of the vertical asymptote. Up on the left, down on the right. I think I'm going to aim for this x-intercept. Now, where should I go? Should I come back down and cross the x-axis? You're not sure where to go? I know, I'll follow this parabola. Follow the parabola, and then he'll look like a parabola on the ends. Same thing happens over here. Up, up, up on the right. So we're going to go down, down, down on the left. If I just let you look at that vertical asymptote, do you see how the graph got split? We're going to aim for this x-intercept right here, and then follow the asymptote. And again, let's cover everything up except for the ends, and I ask you, what do those ends look like? They should look like a parabola. All right, I can't wait to see you tomorrow so we can draw some of these together. Have a great night.